Okay, so this is section 1.4, radical equation. Equations quadratic in form, and also equations which we can factor. So first what I'm going to give you steps for solving radical equation. So the first step is isolate the most complicated radical on one side of the equation. Step 2 is eliminate the radical by raising each side to a power equal to the index of the radical. So I will explain that based on the example. Step number 3, always check your solution, especially here. By plug them in the original equation. I know that we're skipping that, checking our work, but with radical equation, many times you have extraneous solution, which we call fake solution. So you want to check if your solution makes sense by plugging it into original equation. So the note will be that sometimes you may have extraneous solution. So extraneous solution, that's the fake solution. You may get that algebraically, but it doesn't make sense if you plug it in. So that's a fake solution. So you cannot put extraneous solution on my MATLAB because you'll end up wrong. So let me give you an example. Find the real solutions. So real solutions means at this moment I want you to forget about imaginary numbers which we cover. This is the solution which you can see. So find the real solution of the equation. And we have radical. Under radical you have x squared plus 2x. The index of the radical, this is the index. The index is 5. Equal -1. Okay. So first what we're going to do, I'm going to steps which I gave you. We need to isolate the most complicated radical on one side. So that's been already taken care. Second step, you're going to eliminate the radical by raising each side to the power equal to the index. So in our case, index is equal 5. So what we're going to do, we're going to raise each side to the 5th power. If you have a square root, you will raise both sides of the equation to the power 2. So I'm raising both sides to the 5th power. Don't forget that when you have negative, you put that in parentheses. So the power and index of the radical, they undo each other, so that cancels, and you only end up with x squared plus 2x equal -1 to the 5th power, which is -1. So now, like you guys see, this is just quadratic equation. So you need to solve quadratic equation. To solve quadratic equation, you always want to have a 0 on the right side. So I'm going to add 1 to both sides. and we have x squared plus 2x plus 1 equals 0. And it's up to you how you want to solve it. I'm going to solve that by factoring using AC method. Okay, so from AC method, let's just review. Again, A, it's the coefficient in front of x squared, which is 1. B, it's the coefficient in front of x, which is 2. C, it's a number which is by itself. So for factoring using AC method, first what you're going to do, you're going to multiply A by C. So A times C will give you 1 times 1, which is 1. So next, what you're going to do, you have to find two integers, which by multiplication gives you 1, which is our AC. And the same two integers, the same two numbers, by addition has to give you coefficient B, which is 2. So it's like checking, it's like playing game, what's going to work. 1 and 1 will work. So since the leading coefficient is equal 1, so we're creating two factors. X plus 1, which is plus the first integer, times x plus 1 equals 0. And now we're solving two equations. X plus 1 equals 0, and x plus 1 equals 0. So we have x equal negative 1, x equal negative 1. So like you see, we have one solution, repeated solution. That's solution. X equal negative 1, which means the discriminant, if I would like to try to solve it with quadratic formula, it's equal 0. So now, like I mentioned last step, you want to check your work. You want to see if we solve it correctly. So I'm going back to original equation, which is fifth root of x squared plus 2x supposed to be equal negative 1, and I'm going to replace x with negative 1. So that will give you fifth root of negative 1 to a second power plus 2 times negative 1 equal negative 1. So let's see if this is true. So fifth root of 1 minus 2 supposed to be equal negative 1. So we end up with the fifth root of negative 1, which is equal negative 1. And fifth root of negative 1 is definitely negative 1. So this is true. So when your radical has index, which is odd number, you can have negatives on the radical. If the index of the radical is even number, under radical you can only have positive numbers. So let's do the second example. Let's do B. We have, in this case, square root of x squared minus x minus 4 equal x plus 2. So to solve the equation like this, if you don't see the index of the radical, that means it's 2. We're having square root. So the idea is to remove the radical. So we can do it by raising both sides to power 2, since the index of the radical is 2. Okay, so power and index of radical cancel each other, so we end up only with x squared minus x minus 4. It's equal x plus 2. Don't forget that you have expression, so put that in parentheses to a second power. So now what we need to do, on the right side you want to FOIL, so you have x plus 2 times x plus 2, x squared minus x minus 4 equal, and just FOIL that. And if you FOIL that correctly, that will give you x squared plus 4x plus 4. So I'm putting the final solution. Now we're going to solve quadratic equation. So the same idea, to solve quadratic equation, you have to have 0 on the right side. So I'm going to bring everything from the right side to the left side. So we have positive x squared, so I will subtract x squared from both sides. We have positive 4x, I will subtract 4x from both sides. You see positive 4, so subtract 4 from both sides. So everything cancels on the right side, and that's what we want. We want to have a 0 on the right side. And then x squared minus x squared will give you 0. Here we have negative x minus 4x, which is negative 5x, negative 4 minus 4, negative 8. And this is nice because this is just linear equation. So solve for x. We have to move negative 8 to the right side. So let's add 8 to both sides. And we have negative 5x equal 8. Divide each side by negative 5. And we end up with x equal negative 8 over 5. Okay. So this is our solution. I'm going to check your work. So I'm going back to original problem. So the original problem was the square root of x squared minus x minus 4 equal x plus 2. And I'm going to replace x with negative 8 over 5. And when you simplify that, you will end up with, under square root, you will end up with 4 over 25 equal 2 over 5. And square root of fraction, you take the square root of numerator and square root of denominator, and like you see, this is the true statement. So we end up with 2 over 5 equal 2 over 5. This is true. So definitely our solution, x equal negative 8 over 5, it's a true solution. And let me do one with extraneous solution. So I'm going to do one more problem. So example C, we have square root of 3x minus 5 minus square root of x plus 7 equal 2. So in this case, this is a little different because you have two radicals on the left side. We need to go back to step 1. So step 1 is isolate the most complicated radical on one side of the equation. So we're going to check what looks more complicated. I guess the first radical, so we're going to isolate square root of 3x minus 5 on the left side of the equation. Okay, so we're keeping the square root of 3x minus 5 on the left side. The other radical, okay, which is here negative, we have to move it to the right side. So we're going to do the opposite. Since you see negative square root of x plus 7, just add square root of x plus 7 to both sides. Okay, so here that will cancel, and we end up with square root of 3x minus 5 equal 2 plus square root of x plus 7. Okay, since you have an expression on the right side, I recommended to put parentheses. Okay, now what we need to do next, we're trying to remove the radicals. So both radicals has index 2. We have a square root, so that means index is 2. So the next step will be raise both sides to the power of 2. Okay, so I'm going to bring both sides of the equation to the second power. This problem's a little nasty. So second power and square root undo each other, so we end up with 3x minus 5. So it was easy on the left side. However, here on the right side, when you bring something to a second power, that means you multiply this expression by itself. And there's no shortcut. You need to FOIL. You need to FOIL the right side. Okay, so the left side, there's nothing what I can do. So let me just copy 3x minus 5 equal. On the right side, I'm going to FOIL. So 2 times 2, I'm getting 4. 2 times square root of x plus 7 is just 2 radicals of x plus 7. Then you have square root of x plus 7 times 2. Excuse me, that will give you 2 square roots of x plus 7. So number multiplied by radical, you're putting that number in front of the radical. And square root of x plus 7 times square root of x plus 7. Okay, so let's simplify the right side. So we have 4 plus, here we have a like terms because they both have the same radicals. So you're going to just add the numbers in front of the radicals. So 2 plus 2, that will give you 4 square roots of x plus 7. And square root of x plus 7 times square root of x plus 7, let me show you work. This is the same as square root of x plus 7 to a second power. So again, index of this radical is 2. That will cancel. You will just end up with x plus 7. Okay, so from here, again, that will just give you x plus 7. And now I'm going to simplify the right side. So we have 4 plus 7, that's 11, plus 4 square roots of x plus 7. And on the left side, you have 3x minus 5. Okay, so next, we still have a radical. So we're going to follow the steps of solving equations with radicals. So I'm going back here to step number 1. I'm going to isolate the most complicated radical. So right here, this is our most complicated radical. I'm going to isolate it so that positive 11 is going to be moved to the left side. So I'm going back and I still have to isolate the 4 square roots of x plus 7. That means positive 11 has to be moved to the left side, subtract 11 from both sides. And that will give you 3x minus 16 equal 4 square roots of x plus 7, which means 4 times square root of x plus 7. So index of this radical is 2. So to remove the radical, next what you're going to do, you're going to bring both sides of the equation to the second power. Okay, so we bring in both sides of the equation to a second power. So here we have 3x minus 16, which is the same as 3x minus 16 times 3x minus 16. On the right side, that will cancel. Oh, you know what? Maybe I did that too quickly. Let me show work. So you're going to distribute that exponents to the number 4 and of course to the radical. So you have 4 to a second power times square root of x plus 7 to a second power. So 3x minus 16 times 3x minus 16, when you will FOIL, Hold on. It's plus 7. Okay, so when we FOIL, so let's FOIL that, we have 3x times 3x. That will give us 9x squared. 9x squared. Then we have 3x times negative 16. So 16 times 3, we have negative 48x. Then we have 3x times negative 16, which is also negative 48x. And then we have negative 16 times negative 16. That will give you 256. And here we have 4 to the second power, which is 16, times x plus 7. Because again, the index of this radical is 2. So that will just cancel. Okay, so let's start simplifying. So we have 9x squared, negative 48 minus 48. That will give you 96, negative 96x plus 256 equal, and distribute 16. So we have 16x plus 16 times 7, 112. Okay, quadratic equation again. So to solve quadratic equation, we have to have a 0 on the right side. So I'm going to subtract 16x from both sides, and I'm going to subtract 112 from both sides. And that will give us 9x squared. We have 96, negative 96, minus 16. That will give us 112, minus 112x. 256 minus 112, 256 minus 112, that will give us 144 equals 0. Okay, so this is the equation. Let me think. 144, if we can reduce it. Can divide by 3. 112 divide by 9. No, 112 divide by 3. We cannot really reduce it. Okay, so next what I'm going to do, I'm going to solve it. I'm not sure if we can factor that, so I'm going to solve this quadratic equation with quadratic formula. A is equal 9, B is equal negative 112, C is equal 144. So quadratic formula, it's negative b plus minus square root of b squared minus 4ac, and everything divided by 2 times a. So we have negative of negative 112 plus minus square root negative 112 to a second power minus 4 times 9 times 144, and divide everything by 2 times a, which is 2 times 9. So I'm plugging in everything into quadratic formula. So we end up with 112 plus minus. Let's simplify the number on the radical. 112 to a second power. So that's 12,544. And then we have 4 times 9 times 144. Okay. This one minus this one. So under square root, I end up with 7,360 divided by 18. So now let's just break it down into two solutions. So the first one would be x equal 112 plus, let's see if we can take the square root of 7,360. Irrational. 7,360. I'm not sure if I solved that correctly. I think let me just see. Okay, let me see if there is any mistake here. So we isolate that. 3x minus 5, and we end up here 11. Oh, I messed up right here. Have to fix that problem. I forgot to put that x right here. 3x minus 5 plus x. So this is my mistake. I didn't copy that x. So I subtract 11 and we subtracting x here. And that will give you 2x. That should be 2x minus 16. It's equal 4. Okay. And then when we FOIL, I apologize. Okay. Right here, everything here, I'm going to erase it. It was a mistake, and sorry guys. So okay. So again, it's very easy to make a mistake, like I just did it here. I just forgot to move one. Okay, we'll quickly fix it. I noticed that we end up under square root. Usually, the discriminant, which is the expression under square root, you should be able to get the whole number. I ended up with a decimal, so that wasn't like a sign for me. Okay, let's just check work. So here, before I will bring both to a second power, let's just reduce it. And what I'm going to do, I'm going to divide both by 2. So divide this one by 2 and this one by 2, just to reduce it. So 2x divided by 2 will give you x. Negative 16 divided by 2 will give you negative 8. 4 divided by 2 will give you 2 square roots of x plus 7. And now I'm going to bring both sides to the second power. Okay, square. So this one will square and this expression will square, squaring both. So here we have x minus 8 times x minus 8. We'll just FOIL. Here you end up with 4 times x plus 7. So when we FOIL, we end up with x squared minus 16x plus 64. Here that will give you 4x plus 28. Let's solve this quadratic equation. Now we subtract 4x from both sides. I'm subtracting 28 from both sides. That will give me 0. And we have x squared minus 20x plus 36 equals 0. So now I will solve this one using AC method. So first I'm going to multiply a by c, which is 1 times 36, which is 36. Next, I'm going to look for two numbers which product. It's equal 36. And the same two numbers which addition gives you b. And b, it's negative 20. So we have negative 2, negative 18. Okay, so we're creating two factors, x minus 2 times x minus 18 equals 0. And we will solve two equations. Okay, so two solutions. Most of the time, when you have two solutions, one of them probably will be extraneous. So check your work. So let's check if x equal to it's correct. I'm going back to original equation, which is 3x minus 5 minus square root of x plus 7 equal 2, and I replacing x with 2. So this is 3 times 2 minus 5 minus 2 plus 7 equal 2. 3 times 2. So we end up with 6 minus 5, which is 1, square root of 1 minus square root of 9, and we're checking if this is 2. So 1 minus 3, we're checking that will give you 2. We end up with negative 2 equal 2. This is fake. So x equal to its extraneous solution, which you're going to ignore it. Now let's check if x equal 18 is the solution. So we're going to plug it in. We have square root of 3x minus 5 minus square root of x plus 7 equal to. Let's plug in 18 for x, and that will give you 3 times 18 minus 5 minus 18 plus 7 equal to. And we have 3 times 18 minus 5, so we have 3. 54 minus 5, we're having square root of 49 minus 18 plus 7, which is square root of 25. Let's check if this is 2. So you're getting 7 minus 5. We're getting 2 equal 2. This is true. So x equal 18 is the solution. So be careful with them. Always, especially when you're getting two solutions, most likely one of them can be extraneous. Okay. So next in this section, I want to cover off solving equations. We're going to focus on, so this is like second objective, solving equations, quadratic in form, and I will give you example. X to the power of 4 plus x squared minus 12 equals 0. So this equation is not quadratic. It's not quadratic. It's a polynomial equation of degree 4 because power of x, the highest exponent of variable x, it's 4. So this equation is not quadratic, okay? But it's quadratic. So it's not quadratic in x, but it's quadratic in x squared. Because to get x to the power of 4, this is just x squared, bring it to a second power. So this equation is quadratic in x squared. Okay? So to solve equations like this, use substitution, which means replace the middle one most of the time, the middle variable, in this case x squared, with u. Okay, and replace x to the power of 4 with u squared. So look what happened. We're going to use the substitution. We're going to make x squared, which is always in those type of the equation, the middle one, equal u. That's why x to the power of 4, which is just x squared to a second power, since x squared is u, so that's why x to the power of 4 will be u squared. Okay, so x squared is u, x to the 4 power, we're going to have a u to a second power. Okay, so that's what we're going to do first. And next, solve the quadratic equation for variable u. So this is what I refer to. So let me just copy our original equation. Copy, paste. X to the power of 4 plus x minus 12 equals 0. We're using the substitution, right? So x to the power of 4 right now is u to a second power. X squared is u minus 12 equals 0. So we have equivalent quadratic equation, which is equivalent to our original equation. This is original. So again, we make x squared equal u, and we substitute x to the power of 4 with u squared. So next what we're going to do, we're going to solve this quadratic equation for u. Okay, so how you want to solve it? It's up to you. I'm going to solve it by factoring using AC method. So a, it's a coefficient in front of u squared, which is 1. B, it's coefficient in front of u, which is 1. C, it's the number which stands by itself, negative 12. So a times c, it's 1 times negative 12, which is negative 12. So first what I'm going to do, I'm going to find two integers, which by multiplication, it's equal to AC, which is negative 12. And the same two integers by addition has to give you coefficient B, which is 1. Okay, so let's see what's going to work. 4 and negative 3 will work. Four times negative 3, negative 12. 4 minus 3, we're getting 1. And now I'm creating two factors. U plus the first integer, which I find, plus 4 times u, and the second integer, it's negative 3, so that's why in parentheses you see negative 3 equals 0. So we're solving next, we're solving two equations, u plus 4 equals 0, u minus 3 equals 0. We end up with u equal 4, u equal negative 3. Okay, so when you have u, the last step will be, so this is u, this is not done, this is not our solution, because your original problem, it's in terms of x. So you need to solve for x. So the last step will be, okay, replace u with x squared, because that was our substitution. We make u equal x squared, and solve for x. So u equal 4, we know u is x squared. So we have x squared equal 4, And here we have u equal -3, which is x squared equal -3. So let's solve the first one. To solve the first equation, you're going to take the square root of both sides. So you have x equal 2 and x equal -1. Okay. Now here, x to a second power equal -3. This one has no solution because there's no way that the number bring it to the even exponent will give you negative. So we don't have solution here. So this is our solution, 2 and -2. And of course, you should always check, plugging in, and see if we have extraneous solution. But in this case, I'm pretty sure that we solve it correctly. So let's practice. Let's use this method and solve different type of problem. So let's do B. Okay. So here, we're also going to use the substitution. You're going to have the equation x plus 2 to a second power plus 7 times x plus 2 plus 12 equals 0. The long way to solve this equation will be FOIL, distribute 7, and then solve quadratic equation. I'm not recommended. Hint for this one, use substitution. Look what happened. Both here you have x plus 2. That expression repeats twice in this equation. Okay, so what I will do, I will substitute x plus 2 with letter u. So then x plus 2 to a second power will be just u squared. So I will create equivalent equation in terms of u. So that will become u squared plus 7u plus 12 equals 0. And this is quadratic equation. And I will solve this equation for u. So if you see something where substitution makes sense to apply, I recommend it to do it. So you don't need to worry about FOIL and distribution because it's easy to make mistake over there. So A, it's a coefficient in front of u, which is 1. B, it's a coefficient in front of A, it's a coefficient in front of u squared, which is 1. B, it's 7. And C, it's 12. So I'm going to solve it using AC method. So A times C, it's equal to 12. So I'm looking for two integers, which by multiplication gives me 12, which is AC. And the same two integers by addition will give you B, which is 7. So let's see what's going to work. 3 and 4 will work. So now I'm creating two factors, u plus the first integer which we find, which is plus 3, times u plus the second integer which we find, which is plus 4, equals 0. And now we're just going to solve two equations. U plus 3 equals 0 and u plus 4 equals 0. That will give you u equal -3, u equal -4. And next, substitute back. Don't forget that u is x plus 2. So we're going to replace u with x plus 2. So we have x plus 2 equal -3. And we're going to replace this u with x plus 2 equal -4. And just solve two equations for x. Subtract 2 from both sides. And that will give you x equal -5. Subtract 2 from both sides, we're getting x equal -6. Okay, so we have two solutions. So I will put that the solution set is -6, -5. Okay. one more problem like this. You have x to the power of 6 minus 7x to the third power minus 8 equals 0. So here I also going to use the substitution. Use substitution. And when you're using the substitution, you're replacing the middle one. As long like you see that, x to the power of 6, it's quadratic in terms of x to the third power. So I'm going to use the substitution, and the middle expression, x to the third power would be u. So x to the sixth power, which is the same as x cubed square, is just u square. So you're going to build equivalent quadratic equation, which is u square minus 7u minus 8 equals 0. And here you can factor, solve it with AC method, it's faster. So again, C, it's equal 1 times negative 8, which is negative 8. Find two integers which by multiplication is equal negative 8. The same two integers by addition, it's equal b, which is negative 7. So this is AC, this is b. So negative 8 and positive 1 will work. So we will have u minus 8 times u plus 1 equals 0. So like you see, u, and first integer was negative 8, that's why I put minus 8. The second integer was 1, that's why it's positive, you put in plus 1. Solve two equations, so u minus 8 equals 0, and u plus 1 equals 0. That will give you u equal 8, u equal negative 1. And the same type of work, don't forget to plug in and back. So we know that u represents x to the third power. So you're going to replace u with x to the third power equal 8. Replace u with x to the third power equal negative 1. So to solve that, take the cube root of both sides. So that will give you x equal cube root of 8, which is 2. Take the cube root of both sides, and that will give you x equal negative 1. So we have two solutions. So the solution set is negative 1 comma 2. Okay. Next, I want to talk about how to solve quadratic equations using grouping method. Okay. So next one will be solving equations solving equations by factoring. So we use factoring using grouping method. Okay, so let me give you the example. I'm going to explain how to do it using example, but usually using the grouping method when you have 4 expressions, so it's easy to group, or 6 expressions when you have even amount of expressions in the equation. So you can put them in groups of 2. So example, we have x to the third power plus 4x squared minus x minus 4 equals 0. So I'm going to use grouping method here because look what happened. First of all, I cannot apply quadratic formula because this equation is not quadratic. The degree of x, the highest exponent is 3. So this is polynomial of degree 3. So first what you want to do here you want to create two groups. So how are you creating two groups? You're just attaching the parentheses. So that will be group 1, and that will be group 2. So let me just rewrite that. So in parentheses, we have x cubed plus 4x squared plus, and the second group will be negative x minus 4 equals 0. So I'm just attaching extra parentheses. Second, what you want to do, you want to factor lowest comma multiple from each group. And note, sometimes you will need to factor -1. Factor out if there's nothing which you can factor, 1 or -1. Okay, so let's talk about the first group. X cubed plus 4x squared. Here, what you can factor, you definitely can factor x squared. So we're factoring x squared, and we'll end up with x plus 4. So again, how I got that x, I took the original x cubed and I divide by x squared. And that's how I end up with x. Here, how I got that 4, I took my original second expression and I divide by x squared. Okay, so let me just rewrite that. So x cubed plus 4x squared, we're going to rewrite as x squared times x plus 4. And the second group, which you have right here, negative x minus 4, the only thing which you can factor here is -1. So I factor -1 or +1, but if you factor 1, you end up with the same thing. So if you factor -1, you end up with x plus 4. So I factor -1. Okay, so I'm going to rewrite -1 x minus 4 as -1 times x plus 4 equals 0. And when you factor in by grouping, the idea is that in those two parentheses, you end up with exactly the same expression, which we have. Okay. So the third step is factor out the repeating parentheses. So in this case, we're going to factor x plus 4 times, and in the second factor, in the second parenthesis, you're going to put the leftover. So since I factor x plus 4, I only, in front of x plus 4, I have x squared, so x squared goes to the second parenthesis. Since we factor x plus 4, so in the second parenthesis, you're just going to put -1. And now you're just going to use the zero product property. Which means when you have product of two factors, you're solving two equations. The first one is x plus 4 equals 0, and the second is x squared minus 1 equals 0. That will give us x equal -4. Here you will add 1 to both sides. We're getting x squared equal 1, which when you take the square root, that will give you x equal 1 and x equal -1, because the square root of positive number will give you two solutions. So we have three solutions, and it makes sense because, like I mentioned originally, this equation is not quadratic. It's the equation, this is polynomial of degree 3, so we should expect to see three solutions. So you will write the solution that way. The solution set is -4, -1, and 1. I guess we can do one more factoring by grouping. So let me give you one more example. Factoring by grouping. So I will call that example A, and I will do example B. So we have 3x cubed plus 4x squared equal, this is 4, 27x plus 36. Okay. So for expressions, that means we will use factoring by grouping, but first what we need to do, we have to bring all expressions to the left side. So you see 27x, you will subtract 27x from both sides. That positive 36, you have to move to the other side. So we have 3x cubed plus 4x squared minus 27x minus 36 equals 0. Next, what you're going to do, create two groups. Okay, so we're just attaching extra parentheses. So this is 3x cubed plus 4x squared plus negative 27x minus 36 equals 0. Okay, now what you're going to do, factor greatest common denominator, divisor, or lowest common multiple. So factor out, maybe this way, that's better, greatest common GCF factor. So 3x cubed plus 4x squared, the GCF in this case will be x squared, and that will give you 3x plus 4. So again, this one I will rewrite as x squared times 3x plus 4. And from the second group, which is negative 27x minus 36, the idea is if both expressions are negative, you always factor negative. And the GCF, greatest common factor of 27 and 36, here we can factor 9. So I factor negative 9, and that will give you 3x plus 4. So I'm going to rewrite that as negative 9 times 3x plus 4. And when you're solving those type of problems by grouping, you should end up with the same expression in each parenthesis. So now we're going to factor 3x plus 4 because it repeats twice. So when you factor 3x plus 4, in the second parenthesis, you're just going to put the leftovers. So we factor 3x plus 4. So we have x squared in front of it. That goes to a second parenthesis. And we factor 3x plus 4. So in front of 3x plus 4, we have negative 9. So that's what goes to the second parenthesis. Equals 0. And now you're just going to solve two equations. Three x plus 4 equals 0, x squared minus 9 equals 0. So here you end up with x equal negative 4 over 3. To solve this quadratic, add 9 to both sides, you have x squared equal 9, and just take the square root. Square root of 9 has two solutions, 3 and negative 3. So we have 3 solutions also in this problem. So the solution set is negative 3, negative 4 over 3, and positive 3. Okay, so this is the end of section 1.4. I'm going to post it right now for you guys on Canvas. Stop